Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation using variation of parameters method. So let's get going. Problem. Solve y double dash plus y equal to x minus cot x or d square plus 1 into y equal to x minus cot x using variation of parameters method. So we are given a differential equation of order 2. Given differential equation, y double dash plus y equal to x minus cot x. Consider as equation 1. We can write y double dash as d square y by dx square plus y equal to x minus cot x, and write d square y by dx square as capital D square y using differential operator d, capital D I mean. Now take y common from the two terms of LHS. We'll get d square plus 1 into y equal to x minus cot x, which is in operator form. Equation 1 in operator form is this equation. Consider it as equation 2. Say f of d into y equal to some function of x, where f of d is d square plus 1 and function of x, r of x is x minus cot x. Now we'll find the solution to the given equation or the general solution using y equal to yc plus yp. Here yc is a complementary function, yp is a particular integral. We'll find yc using the auxiliary equation and later using yc we'll find yp. Now coming to the auxiliary equation. The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of d equal to d square plus 1, right? Let's replace the differential operator by m, so that we'll get f of m equal to m square plus 1, and the auxiliary equation becomes m square plus 1 equals to 0. We need to find roots to this equation. We'll write m square plus 1 as m square equal to minus 1, then m equal to plus or minus square root of minus 1. Since square root of minus 1 is I, so we'll get m equal to plus or minus I. We know that when m is a pair of complex conjugate roots, then the complementary function looks like yc equal to e power ax into c1 cos bx plus c2 sin bx. In case of a0, we'll get e power 0 into x, which is e power 0 into c1 cos bx plus c2 sin bx. Since e power 0 is 1, so this gives us 1 into c1 cos bx plus c2 sin bx, which gives us c1 cos bx plus c2 sin bx, right? Let's now write our complementary function using this formula. Complementary function yc equals to, just compare plus or minus I with plus or minus ib, then for b equal to 1 we'll have c1 cos bx plus c2 sin bx, which gives us yc equals to c1 cos x plus c2 sin x. Therefore yc equals to c1 cos x plus c2 sin x. Now using this, we'll find yp. Let yp equal to, now replace the constants or parameters with some functions of x, a and b. We'll get yp equal to a cos x plus b sin x, where a and b are functions of x, and compare yc with c1u plus c2v, or yp with au plus bv, so that you'll get u and v, where u is cos x and v is sin x. See, u is cos x and v is sin x. Here we'll find a and b using formula. A is given by integral minus v into r of x by uv1 minus v1 into dx, and b is given by u into r of x by uv1 minus v u1 into dx. So if you notice, we are having uv1 minus v1 in both the formula. So we'll begin with uv1 minus v1, and later we'll find a, b, yp, and finally we'll substitute yc and yp in y equal to yc plus yp to find the general solution to our problem. v1 is nothing but derivative of v, and u1 is nothing but derivative of u, or u1 is u dash, v1 is v dash, we can say. This gives us u cos x into v dash sin x dash minus v into u dash. This gives us cos x into derivative of sin x with respect to x is cos x minus sin x into derivative of cos x with respect to x is minus sin x. Right? This gives us cos x into cos x, cos square x, minus into minus plus, sin x into sin x, sin square x. Or we can write this as sin square x plus cos square x, since we know that sin square theta plus cos square theta equal to 1. Right? So you'll get 1. Therefore, uv1 minus v1 equal to 1. Now let's find a. A is given by integral minus v into r of x by uv1 minus v1. This equals to integral minus v sin x into r of x, x minus cot x by uv1 minus v1 into dx. This is equals to minus sin x, or minus integral sin x of x minus cot x into dx. This gives us minus of integral x sin x dx minus integral sin x cot x dx, or minus integral x sin x dx minus into minus plus integral sin x cot x dx. Right? See, here in the integrand of second integral, we are having sin x into cot x, right? We can write cot x as cos x by sin x, where sin x gets cancelled and you'll get cos x, right? This equals to minus integral x sin x dx plus integral, it's cos x, okay? Cos x dx. Now evaluate integral x sin x separately. Let's evaluate integral x sin x. So here we are going to apply integration by parts formula. Integral u dv equal to uv minus integral v dv. Right? Here the integrand is of the form product of polynomial and trigonometric function, right? Let's consider the polynomial function as u and the remaining part as dv. So we have u equal to x and dv equal to sin x dx. Right? Here differentiate on both sides with respect to x. We'll get du by dx equals to derivative of x with respect to x is 1. From this we'll get du equal to dx, right? And here we are going to integrate on both sides to find v. This gives us v equal to integral sin x dx is minus cos x. Now apply this formula. Integral u dv equal to uv, that is x into v, minus cos x minus integral v du, which is dx. This gives us minus x cos x minus into minus plus integral cos x dx, which gives us minus x cos x plus integral cos x is sin x, right? Therefore, integral x sin x dx is minus x cos x plus sin x. Since integral x sin x dx is minus x cos x plus sin x, so this becomes a equal to minus of integral x sin x dx is minus x cos x plus sin x plus integral cos x dx is sin x, which gives us minus into minus plus x cos x minus into plus minus sin x plus sin x. Here minus sin x plus sin x gets cancelled and you'll get x cos x. Therefore, a equal to x cos x. Let's now find b. B is given by integral u into r of x by uv1 minus vu1. This equals to integral u cos x into r of x, x minus cot x by uv1 minus v1 is 1 into dx. This gives us integral cos x of cos x minus cot x into dx, which gives us integral x cos x dx minus integral cos x cot x dx. Just evaluate integral x cos x dx and integral cos x cot x dx separately. Let's evaluate integral x cos x. Here we are going to apply integration by parts formula. Integral u dv equal to uv minus integral v du. Here the integrand is of the form product of polynomial function and trigonometric function, right? Consider the polynomial function as u and the remaining part as dv. So we have u equal to x and dv equal to cos x dx. So here we are going to differentiate on both sides with respect to x. We'll get du by dx equals to derivative of x with respect to x is 1. This gives us du equal to dx, right? And here we'll integrate on both sides to find v. This gives us v equal to integral cos x dx is sin x, right? Now apply the formula integral u x into dv cos x dx equal to uv, that is x into sin x minus integral v into du, which is dx. This gives us x sin x minus integral sin x dx is minus cos x, which gives us x sin x minus into minus plus cos x. Therefore, integral x cos x dx equal to x sin x plus cos x. Valued cos x cot x. Let's consider the integrand cos x into cot x, right? Since we know that cot theta is cos theta by sin theta. Now just replace cot x with cos x by sin x, right? This gives us cos x into cos x, which is cos square x by sin x. Since we know that sin square theta plus cos square theta equal to 1, this gives us cos square theta equal to 1 minus sin square theta, right? We'll just take this sin square theta to RHS, then we'll get cos square theta equal to 1 minus sin square theta, right? Now just replace this cos square x with 1 minus sin square x. You'll get 1 minus sin square x by sin x. In the numerator you are having two terms and in the denominator you are having one term, so we can split this into two terms, say 1 by sin x minus sin square x by sin x, which gives us reciprocal of sin x is cosecant x minus 1 sin x gets cancelled from the numerator and the denominator, you'll get minus sin x, right? Therefore, cos x into cot x equal to cosecant x minus sin x. Since cos x into cot x equal to cosecant x minus sin x, we'll replace the integrand by cosecant x minus sin x. Now just replace the integrand with cosecant x minus sin x. This gives us integral cosecant x minus integral sin x dx, right? Since we know that integral cosecant theta d theta equal to log mod cosecant theta minus cot theta, and integral sin theta d theta is minus cos theta. So the expression becomes integral cosecant x dx is log mod cosecant x minus cot x minus integral sin x dx is minus cos x, right? This gives us log of cosecant x minus cot x minus into minus plus cos x. Therefore, integral cos x cot x dx equals to log of cosecant x minus cot x plus cos x. Since integral x cos x dx is x sin x plus cos x and integral cos x cot x dx is log of cosecant x minus cot x plus cos x, now the above equation becomes b equal to integral x cos x dx is x sin x plus cos x minus of integral cos x cot x dx is log of cosecant x minus cot x plus cos x. This gives us x sin x plus cos x minus log of cosecant x minus cot x minus into plus minus cos x, right? Here cos x minus cos x gets cancelled and you'll get b equal to x sin x minus log of cosecant x minus cot x. Therefore b equal to x sin x minus log of cosecant x minus cot x. We got b and a. Let's now find yp. Yp is given by a cos x plus b sin x. Substitute a and b here. We have a x cos x into cos x plus b x sin x minus log of cosecant x minus cot x into sin x. This gives us x into cos x is cos square x plus x sin x into sin x sin square x minus sin x log of cosecant x minus cot x. Now take x common from the first two terms. You will get x times cos square x plus sin square x minus sin x log of cosecant x minus cot x, or you can write the first term as x times sin square x plus cos square x minus second term remains the same. Since sin square theta plus cos square theta equal to 1, so we can replace sin square x plus cos square x with 1. You'll get yp equal to x into 1 minus sin x log of cosecant x minus cot x, which gives us yp equal to x minus sin x log of cosecant x minus cot x. Therefore yp equal to x minus sin x into log of cosecant x minus cot x. Now coming to the general solution, we got yc and yp, so we can find general solution using y equal to yc plus yp now. Therefore the general solution is given by y equal to yc plus yp. Then y equal to yc c1 cos x plus c2 sin x plus yp is x minus sin x log of cosecant x minus cot x, which is the required solution. Therefore y equal to c1 cos x plus c2 sin x plus x minus sin x log of cosecant x minus cot x is the required solution. This completes the problem. So this is all for now. I hope you will understand. We'll see you in the next video. Until then, bye bye.